Good. Good. I used my bestest handwriting so that even though you may not be comfortable with that word, you can at least darn well make out the letters. I think matrices, matrices. Does anyone know what that word means? That's a mattress, bro. Like I'm going to Denver Matrices Company. Matrices is the, like in geometry, if you looked at a triangle, if you looked at one of its corners, you'd say there's a vertex. If you refer to all of them, you refer to them as the vertices of the triangle. The plural of the word matrix is matrices. So we will maybe, I don't think it's in the Algebra 2 standards anymore, but if time permits, which it usually doesn't, we could do a short unit on just the basics of matrices. You really don't need to know squat about matrices in order to do this the way we're doing it today and Monday and probably Tuesday. This will take a bit. But you can add matrices, you can multiply them, you can invert them. There's all sorts of applications. You'll take, if you go into college, really, regardless of any major, if you take any major that involves a mathematics or science in any way, engineering, you're gonna have to take a course on linear algebra, where basically all you'll do for 18 weeks is just study matrices. And so today we kind of get in and talk just about how to use a matrix for a very intentional purpose, as opposed to like, how to add matrices or how to define the entries in a matrix and stuff like that. That's a totally different chapter, and it's not something we really need to discuss at this point. But there's an alternative method, and I will preface this lesson with this. You're probably not going to love this, just FYI, but you guys surprise me sometimes. And things that I go into and I'm a little leery of, you sometimes go, I like that. So you can kind of let me know here in about 10 or 15 minutes what you think. But there's another way to solve a system, and it involves matrices. And at some point, you can combine this knowledge, hopefully that you acquire today. If I don't dumpster fire this lesson, you can combine this knowledge with technology to eventually use matrices in a really efficient manner to solve systems. I mean, there's always photomath, right? Like you could always just photomath a system and say, boom, solve it for me, right? But that's pretty ghetto. Um, so anyways, hopefully it all comes together for you at some point. But today, the idea, my mission for the day is like 30 minutes from now, I want these kids to be able to solve a system by row reducing a matrix. That's the goal. So it's not going to make sense for a few minutes. Just ride along with me, and then the light will come on and you'll be like, okay, I'm good to go. So I have a bunch of examples scripted here. I've worked through all of them except one, quite frankly. And they do vary from, I think, pretty easy to pretty uncomfortably difficult. But I did find a workaround thanks to some guy on YouTube. I found finally a way to do this that does not, good news, does not involve fractions. And that's great news. So the people that took my classes before you, if they've remembered anything about what I taught them, they would tell you that this unit was pretty much the devil himself. But with the fractions out of the way, I think you'll find this to be relatively fine. You just have to be good at keeping track of parts and pieces, which if you're prone to little mistakes, you really want to watch out for that because it'll get nasty. So, good. All right, let's get to it. So for our first example, we have, well, obviously they're all going to be 3x3 systems. That's what we're doing is we're solving 3x3 systems. We're just doing it using a matrix. So for our first example, we're going to do this one. And honestly, this is one that I don't know that I worked through in its entirety. But based on the size of the numbers, I can tell you it shouldn't be all that unpleasant. We won't get through 6 examples today. I don't really know what the best course of action is. I can tell you that there will not be an assignment today because the primary focus today is just going to be us solving systems using this method. And then Monday will be a big work day, as will probably Tuesday. These take a while. Talk to my counterpart over in Pine Bluffs. We talk every now and then about like what are we still doing, not doing, what's in the standards, what's not. And this one just is there. This one just doesn't go away. So what you're going to learn today is called row reduction. I'm going to put that up here. I'll write it in a different color. So there's all sorts of terminology here, row reduction, echelon form, all that. But you just need to know this process that we're undertaking here is called row reduction. And so the first thing we want to do is get out of our comfort zone. And if I gave you this problem right now, just like yesterday, and said solve it, you hopefully autopilot would kick in. And you might look at that first column and say, okay, I'm going to turn all those into 15s, or you go to the second column, I'm going to turn all those into 60s, or the third column, I'm going to turn all those into 20s. Whatever would float your boat. Like you've done this before, right? Say it's your first rodeo. But we are going to think differently now. We're going to completely retrain ourselves in a new method on how to do this. So step one is to rewrite it as a matrix, and I'll show you what this is going to look like. So first off, I don't think you've seen this before. Matrix notation. Matrices, by the way, look like this. They have square brackets on the left and square brackets on the right. If you take liberties with that, it's no longer going to be considered a matrix. So in the world of math, the tall square bracket followed by a tall square bracket is our indication that we're building a matrix of elements inside of that. So what we're going to do is we're going to take off first these 9 elements right here, and we're going to build a 3x3 matrix out of those. Very simple, nothing difficult about this at all. So like when you're doing problems, you won't copy it onto your paper like I just did. You would have already copied it in this matrix form, which looks like this. -5, 4, 5, -5, 5, -2, 3, -3, -4. So that's the 3x3 matrix. And now in order to start it and say to the world, hey, I'm building a matrix, I need to build my square bracket on the left like this. So what we have right now, if I wanted to end this matrix right now, I would put another square bracket on the right, but I don't. What I want to do is something called augmenting. I'm going to augment, and that word has meaning in English, like it's like to attach something or to like kind of supplement. I don't know if if I'm saying that the right way, but like to augment something is like to add on to it. So I'm going to draw a vertical line, and I'm going to augment on now a second matrix. And this second matrix is an awkward matrix. It's just a matrix composed of these 3 numbers right here. So that's 3 rows by 1 column. We call that a 3x1 matrix. And so I'm going to take those 3 elements and I'm going to augment them onto the right like this. So I'm going to go ahead and slide the screen up now because this really is now what we need for today. Is we have a 3x3 augmented with a 3x1. And now what we're going to do is we're going to manipulate just numbers. We won't even talk about X's, Y's, and Z's for quite a while yet. But that's the first step, is to pull out, those are coefficients. So we're pulling out just the numbers of the system and ditching the X's and the Y's and the Z's. Any questions so far? Okay, so what we're going to do now is we have missions. And as I sat and worked yesterday, I was thinking, like, what can I say to these people? Because I just know from my experience as a teacher and as a student that this process can get a bit overwhelming. Job number 1 is to make, so this is going to be step 1. Is to make those zeros. It's a very, very exact science. You're not to take liberties with this. You're not to do things out of order. There's a reason we attack a matrix from left to right like this. And so the first 3 or 4 or 5 minutes of this problem is going to be us just attacking those numbers I put a purple box around and saying, how can I make those into zeros? Don't worry about the number up on top. That's the new method I learned yesterday was I don't care. The old version of me used to say that -5 in the top left corner has to be a 1. The newer, wiser, better teacher version of me now knows that that's actually not true. We can deal with that later. So our only mission in step 1 is to take those two numbers in column 1 and make them into zeros. Don't worry about the -5. Yeah. Yes. I mean, you're comfortable with how this is going to work. You're comfortable with row operations. I know you are because we've done this before. Like, you know how to manipulate things to make other things go away. It's the essence of elimination. It's what we've been doing. So if you think about, well, you say this, and just every time I say something, because this is a tough lesson, it's tough to teach and tough to learn. Every time I make a new matrix, something's not going to change. Let's be clear about that. And so what's not going to change is the top row. So let's leave this one, recopy it. Got it? He's like my worker bee. And so the top row is my worker. He's the one that's going to stay solid. And it's the bottom two rows that are going to change now as I do row operations. And so in order to make a zero, what I'm going to do is I'm going to perform combinations. So like for this one, I'm going to write this down and you're going to tell me whether or not you buy it. Like, does this make any sense at all? I'm going to do the opposite of row 1 plus row 2. And notice where I put that. I put it right next to where the new row 2 is going to go. You say to yourself, well, why would I do that? Well, let's think about what the focus of that one step is. I don't give any craps about the 4 and the 5 over here, or this and this, or this and this. Those things I just crossed out. I'm about to uncross them, but the point is, they're not my concern right now. My concern, and my only concern right this moment, is can I make that guy a 0? And the answer 100% of the time, literally 100% of the time, is yes, I can. And in this case, it's relatively simple, right? I say to myself, if I take that -5 up above him and I opposite him, what does he become? +5. And then if I add him to the dude right below him, what do I get? Perfect. So we have a plan in place. So I'm going to take the opposite of everything in row 1. I'm going to add it to everything in row 2. And then as I complete that step, I'm going to be building a new row 2 with a 0 where I want it, right? So as I complete now row 2, focus. This is the hard part, is you got to stay focused. And the more, sometimes like writing numbers down as you go helps. But I'm trying to think, like, my son and I were talking about this. He's an engineering major over at UW. And he said, maybe you should have them write down every little thing. And I was like, man, I don't want to like punish them. But if you find yourself struggling with keeping track of numbers in your head, then you're going to be someone who needs to go and write numbers down along the way. Okay, you'll know what I mean. So what's the opposite of -5? What's 5 plus -5? Good. So we have a new entry. Mission accomplished right there. Okay, I'm going to switch back to white. That 0 is important. I wanted that. Everything else that happens now is collateral damage. It's not unimportant. It's just not what my focus was. What's the opposite of 4? -4 plus 5? 1. Jackpot. Okay, what's the opposite of 5? -5 plus -2? Good. And these operations get infinitely harder to calculate as we start to have to bring multipliers in. This one, we got lucky because all we had to do was just switch the sign of 1 and add. This next one, we're not going to be quite so lucky because 5s and 3s don't play well together, right? So we have to still do our last column over here. What's the opposite of 9? -9 plus 5. Okay, 1 down, 1 to go. Still okay? All right, our next mission now is to make the number that I'm going to circle in green into a 0. And in order to do this, I want to use my worker bee. I want to continue to go back and hit that top row. That one row that doesn't change is the one I generally want to involve in this practice. So you don't have to. You could use row 2 and row 3, just FYI. But it's best practice to always use the row that you're not going to change. Trust me on this one. So I'm going to take and I'm going to modify rows 1 and 3 in some way that allows those first two numbers to collapse away. So you got this good spidey math sense. Like how can a -5, let me put little check marks next to them. How can that number and that number interact to make a zero? This is where it gets hard. And if you can, like, if what I'm about to do doesn't make you uncomfortable at all, then you're generally going to be fine. It's just hard. It might just be my adult ADD or something, but like I find it hard to track numbers in my head. So what I found myself doing yesterday was jotting down a lot of scrap work as I go. So here it goes. You said it perfectly, by the way. Multiply the top row by 3 and the bottom row by 5, and then add them as you go. That's a lot to ask of your brain. So here we go. Right here, times 3 is -15, times 5 is 15. Add them together, you get 0. Mission accomplished. Like if that didn't work, then we were wasting time. Like we knew that was going to be 0, right? Now here we go again. Keep track of what you're doing. Multiplying the top one by 3, the bottom one by 5. What's 3 times 4? What's -3 times 5? What's 12 plus -15? Yes. And that right there is the moment where you might just go, what? How did you get that? And you're then a candidate for someone like me who likes to write down scrap work as I go. I just keep like a little note card or a piece of scrap paper handy. And as I get those numbers in my brain, I just jot them down. And I remember, okay, 3 times this is 12. 5 times this is -15. And then my poor little brain can actually see them so that when I track in a number, I know what to put. Continue with your 3, 5, add. What's 3 times 5? What's 5 times -4? Add those together. Okay, we have a new entry right here. And then keep going. What is 3 times 9? 27. What's 5 times -3? 27 plus -15. Take this or leave this. You've known me long enough by now to know that I'm not going to like lie to you. Good advice is to do those little red numbers. If you find yourself missing problems, take, like I've done, the little red numbers and show those numbers so your brain can see them. It'll help. So any questions on step 1? Step 1 was to fill in the purple box with zeros. Are we good there? Okay, so I'm going to erase some stuff now. I'm going to scroll over to here. Step 2. Is to make those zeros. You'll notice that you may not notice this yet, but we're working in a diagonal pattern. I've accomplished mission 1, and it was to make the only non-zero in column 1 be the top number. Now, as I work my way down diagonally to the left, or to the right, excuse me, then I want that 1 in the center to stay as a non-zero, but the guy above him I want to kill, and the guy below him I want to kill. So my worker bee this time is this one. So that's going to be the one that plays a part in all of the calculations that I do. Got it? And we love this one because there's a 1 there, and 1s are really easy to manipulate, right? But bear in mind, as you change, your worker bee row is going to change too. So as I shift over to my new matrix, I want to rebuild the matrix like, make sure I have white here. I'm going to switch to this. And I'm going to leave that row alone. So I want 0, 1, -7, -4. And now the rest are going to change. As I modify above and below, as I kill to make zeros above and below, my top and bottom rows change. So if I point to this right here with a red arrow, you're on my radar first. I need to make you a 0. What row operations could I use to make him become a 0? I don't want to divide by 4 because then I'm going to get a mess of fractions there. So remember, everything is going to involve worker bee. Let me circle him again for you. This row right here is your buddy. So how can I manipulate this number that I just circled in red? If I multiply that row by -4 and then add it up to the dudes above it, I will get my 0. So that means I'm going to put this in purple over here. I'm going to do -4 R2s plus R1. and you may not be ready for me to say this yet, but if you're really in tune, I'm going to say this, and I'll say this again and again and again as you start to ask questions like, why can't I do this, or why can't I do this? The beauty is that this 0, I'm going to circle him in white. By using this row as my worker bee, that 0 will not affect the things above and below him. That's important. We work hard to make zeros, and if we start using the wrong row as our worker bee, that number -5, if you let him be your worker bee, then he's going to go down and flush and ruin all that hard work that you put in. So if you use a row where you already have zeros in certain places, if you use that, the correct rows as your worker bees, then you won't mess up the work you've done so far. That may not make any sense yet, but please always use the row that's not going to change as your worker bee. That's important. So let's do this. -4 times the middle row plus the row above it. So sorry, I've kind of vandalized, but just follow my mouse. You can kind of see where I'm moving my mouse a little bit here. So what's -4 times 0? 0 plus -5? -5. So that one did not change. That's good. You'll find that happening. That should happen. When there's zeros involved, if you play your cards right, the zeros cause things to not change above them and below them. That's what we want. So again, follow my mouse here. What's -4 times 1? -4 plus 4? Jackpot. And that's what we came for. Right there. Everything else is just collateral. Follow my pen again. What's -4 times -7? +28. What's 28 plus 5? 33. Good. Follow my pen again. What's -4 times -4? 16 plus 9. Mission accomplished. And again, I'll write it in yellow because I want you to see that why did we come here? To do that. That yellow 0 is why we did what we did. Okay. The next mission is to look down here where the green arrow is. Say it's your turn. I'm going to make you a 0. And my worker bee is going to continue to be row 2. And so I need to do a row operation that involves worker bee, row 2, combined with row 3. And if you have any idea what's going on right now, you should have no trouble answering this question. How will I combine rows 2 and 3? Just by 3. I don't need any negatives because there's already a positive-negative dynamic. So this is going to be 3 R2s plus R3. And you always want to put these statements, these purple statements that I'm writing, next to where the product of that is going to be. Like you say to the world, this is what I'm doing, and I'm writing it next to where the answer is going to go. Don't ever put it anywhere else. That's going to confuse everybody. So here it goes. Triple the middle row plus the bottom row. What's triple 0? 0 plus 0, 0. And again, if that had changed, you would see right away, well, now I have to backtrack. So frustrating when you do this wrong and you realize that you worked hard to put a 0 and you jacked it all up and you got to go back now and start over. Don't mess up the work you've done. What's triple 1? 3 plus -3. And I'm going to switch colors again and write that because that's important. That 0 is mission accomplished. Okay, I'm switching back to white. What is triple -7? -21 plus -5. And then the last one is triple -4, -12 plus 12. We're 2/3 of the way home. Would you like to guess at this point in this problem what the next step is going to be? Correct. So I'm going to circle again in purple because I want you to understand the mission. The mission now is to make this and this zeros. You still along for the ride? Are you still feeling good-ish? Now, these numbers are pretty much terrible, right? However, I'm going to teach you something, and I'm hoping you hear this because this will be, I try to give you good advice. This is really good. You ready? You sitting up? You listening? At any point in this process, you can take an entire row of the matrix and divide it to make your life simpler. And I was just sitting here thinking to myself, wouldn't it be really, really rad if that number 26 were more cooperative? Because right now, making a 26 and a -7 go away is like, I could do it, couldn't I? And a 26 and a 33, I could do it, couldn't I? But I don't want to. Instead, what I'm going to do is I'm going to take a quick moment, you are too, and we're going to divide this entire row by -26. And why would I do that? Well, because I can. First of all, are all the numbers in that green oval divisible by 26? Yes. And you can do that at any point. There's going to be a problem later when we see a great opportunity. I had one in the notes where I had a 250 and a 750, and I was about to embark, and I was like, wait, why don't I just divide them both by 250, knock it down to a 1 and a 3? So in this case, I'm going to take that entire row and rewrite it as 0, 0, 1, 0, which seems almost like cheating, but it's not. So this is where we're at in the process right now. How's your comfort level right now? Like 1 to 10. 1 is I have no idea what's going on. 10 is like I'm good to go. Feeling it? 10, you feel good? That's pretty good. Just tired? I'm sorry. All right, so our mission now is to make the two numbers above equal 0. And I don't think we're going to have a lot of difficulty with that because of that power play that we just did, where we turned that 26 or whatever into a 1. Now we can use this with the greatest of ease. So first off, our worker B row is going to be the bottom. So please copy that one down again. 0, 0, 1, augmented 0. All right, so for our first row operation, what are we going to do to, let me circle one of them so that we all have a clear objective. How can I make that, the one I just circled, be a 0? Correct. So we want to do 7 R3s added above to R2. Let's go ahead and do that first, and then we'll come back and talk about the other one. Let's not bite off more than we intend to chew right now. So you should see a lot of things now that don't change. As you work your way across, there's less work to have to do each time. It's nice because of the work we've already done. So what is 7 times 0? 0 plus 0. So I can keep my 0 there, of course. What's 7 times this 0 where I'm moving my pen? 0 plus 1. Nice. What is 7 times 1? 7 plus -7. Jackpot. Switching colors. That's important. That's why we came. That's what we're here for. And what is 7 times 0? And 0 plus -4. Almost there. Now we need to do one more row operation, one more magic trick to make this one that I'm now circling again in purple become a 0. And what is that operation? Nice job. You guys are pretty amazing. We're going to take the bottom row times -33, and we're going to add it up to the top row. So that's -33 R3s plus R1, right? And again, as we work our way across, we should see a lot of things that don't change because of the order that we're doing this in. The zeros we've already placed are going to help us keep things simple. So as I do -33 times that is 0, plus -5 is an unchanged -5. -33 times 0 is 0, plus 0 is 0. And this will be really the hardest of the calculations. And actually, that's a lie. It's not even hard at all. So it would be sometimes, not in this case. What's -33 times 1? -33 plus 33 is 0. And again, I'll put that in yellow because, well, that's why we came here. And finally, what is negative 33 times 0? What's 0 plus 25? Now, you may not know it, but we're done. And I can tell you right now that the answer to this problem is negative 5, negative 4, 0. We're done. Now, the question becomes, well, why is that true? Well, let's think about this. Remember when we, go ahead, Coop.
Negative 5 and negative 5 is 25, so actually,
Do you remember what would have been right here? Can you see where I'm moving my pen before? That used to be an X, didn't it? And what used to be right here where I'm moving my pen? A Y. And what used to be right here? A Z. So if we put those letters back in to help ourselves understand this concept, you now see that by row reducing the matrix that way down to that echelon form with the diagonal non-zeros, then you've got just simple little fourth grade equations to solve. If negative 5x equals 25, x obviously equals negative 5. And then these next ones kind of solve themselves. You won't always get ones here, but you did. And so that means like these answers are just ready to roll. What do you think? Good, good. Let's go again. Again, I know it's kind of inefficient the way we're doing this now. You generally, again, wouldn't copy this. You would only copy the matrices, which, but for the sake of notes, they got it. The information's got to get out there somehow. So let's go ahead and take this now and write it as a matrix. So we're going to start on the left with our square bracket, nice and tall. Leave yourself plenty of room. What's my top row going to say? Nice job. Way to catch the 0. Can't fool you. I got to wake up way earlier than that to fool old Brycey over there. How about my second row? What's it going to say? And my last row? 2, -1, -1, and 10. So I'm going to go ahead and scroll away, and there it is. I remember when I worked this one, I thought this will be more comfortable, I think, for you than that last one. So the first one's always going to be the worst, I think. So here we go. What's mission number 1? Get the zeros in the first column, right? And so you're trying to murder those two numbers that I just circled. And we can do some pretty basic row operations, I think, to make that happen. Who's my worker bee? Yeah, so copy him down. So -3, 0, 1, augment, -2, jackpot. Here we go. What are the row operations specifically that we're going to do? Let's one at a time, okay? Keep your focus. I'll circle in yellow first. Let's kill that guy. What do we do? There you go. Perfect. We need to double row 1 and just simply add it to row 2. Let's go through and perform that operation. It shouldn't take us long now that we're kind of in the groove. What's double -3? +6, 0. And I'm going to quit switching colors now. You get the idea. All right. What is double 0? 0 plus 1? 1. And I'm sorry that my 0 that I just wrote kind of looks like a 6. I'm going to fix that. It should look like a 0. That's better. Okay. What's double 1? 2 plus -2? 0. You see some nice, this is a good problem, right? Sometimes things, middle row's done. Yeah. Unfortunately, sometimes it might get messed up because of the order that we have to do things in. But yeah, as it stands, middle row's like jackpot. And then what's double -2? -4 plus -2 is -6, good. And we need another row operation to murder off this one I'm going to circle in green. And what's that row operation going to be?
Double R1.
So double R1 plus triple R3. There you go. So we're doubling the top to make him -6, and we're tripling the bottom to make him +6. And everything else that happens is just whatever happens, happens. I did, didn't I? Thank you. Here. Thanks, appreciate it. All right, so we're doubling the top, tripling the bottom, adding them together. So try to keep track. And again, this is where you might want to, when you got to multiply 2 different rows before you add, that's when writing the scratch work down can sometimes help. So it's up to you. What's double -3? And what's triple 2? So -6, +6, as expected, 0. Right? Double the top, triple the bottom. What's double 0? What's triple -1? 0 plus -3. Okay. Double the top, triple the bottom. What's double 1? Double 1. Double 1. 2. Triple the bottom. So you have +2 and a -3, and you add them together. What do you get? -1. Double the top, triple the bottom. What's double the top? -4. Triple the bottom. What's -4 plus 30? All right. Give me some good news. What's our next mission?
All you have to do is
Correct. Remember, our next mission is to take these 2 numbers that I'm circling in purple and make them zeros. But the way the cards fell in that first step was that, hey, we got a bonus 0. It's like the problem just naturally was like, hey, oh, thank you very much. So really, we only have to take the bottom one, the -3. And our worker bee this time is going to be the middle row, right? So the one where you're not trying to make zeros is always your worker bee. So I'm going to copy that row down. I'll head back over here. I'll just slide it across like I've been doing. I'll do that. I don't know how much room I have horizontally. I guess we'll find out. So worker B row is going to stay 0, 1, 0, augment, -6. And a top row can actually stay too, right? We don't have to modify him. We just have one job to do. And it's going to be a combination of worker B and the one you're trying to modify, generally is how that's going to go. And so what is the row operation that I want to use to make a 0 down here?
triple row 2.
Simple. We should be able to handle these numbers with the greatest of ease. So we're tripling the middle and adding the bottom. What's triple 0? 0 plus 0, 0. What is triple 1? 3 plus -3. Good job. And what is triple 0? 0 plus -1. -1. What's triple -6? -18 plus 26. Dope. And again, we've got a lot of good, I picked this one for a reason. We've got a lot of good stuff happening here. And again, our mission now, I'm going to scroll across again. Our mission is to make these 2 numbers equal 0, but one of them already is. And so our work is lessened. We want to make that top one into a 0. So this time, who's our worker bee? Bottom row is worker B. So when we copy this down, we want to make sure that we copy the bottom row across. So 0, 0, -1, 8. And the operation that we're going to, and I can also copy down, I can copy this one too, can't I? Yeah, you're right. I can just do a nice simple operation. Row 1 plus row 3 is going to go right there. So I think this, I feel like this would be, if you were going to rank these row reduction problems, scale of 1 to 10, 10 being demonic, this is like a 1, right? This has been as pleasant as it can possibly go because we're almost there. So now when we add them together, row 1 plus row 3, we get 0 plus negative. So just kind of go back to where my pen is. 0 plus -3 is -3. 0 plus 0 is 0. -1 plus 1 is 0. And what's 8 plus -2? And we're done. So now we have to be able to decipher. And if you don't know what I mean, then I guess I should have done a better job of being clear. Those three numbers are really important, right? Those are going to be the coefficients of X, Y, and Z. And then I just have to solve the little equations that they imply with the numbers on the right. So in looking at these two, I'll circle them in green. What's X? Nice. In looking at these two, what's Y? Yeah, it's like already done. And in looking at these last two, what's Z? Done. How'd that one feel? Good. Okay, we don't have a lot of time, but I'd like to put one up here and maybe try to help you a little bit less with it. Are you okay with that? All right, let's give it a shot. And I'll work a little bit to get caught up to you as we go, but I'll try to pull the reins back a little bit and kind of let you try this one more by yourself. So let's see. Oh, you know what? I do have to get you started on this one though. I don't have to. I'm going to because there's a pro tip. I can't believe I almost let this one go. Yeah. On my note card, I labeled them as easy, medium, and hard, and this one got an easy label. So the only reason though I want to get a little jump start with you is because there's a trick, and I don't expect that you would just know the trick. But here it goes. Step one is just to, of course, build your matrix. And so top row of my matrix is going to say what? Mm-mm. 0, -7, -4, -1. Second row, 1, 1, 1, -1. Third row, so anything stand out? Yeah, well, yeah, that's not what I was expecting you to say at all. I was just, I ask this of you, and you probably will know the answer based on the tone of my question, but is that going to be a problem? It is. Yeah, you don't want a non-zero element to start the game right away up there in the upper left-hand corner. That's my guy. That's like my building block because I want to start with something there not named 0. So there's actually a really cool trick that you can do. And this is a row operation, which I don't think you've probably ever seen before, but it goes like this. What do you think it means when I put a double arrow? Correct. And you might think, well, that seems obvious. Well, I had to say it out loud. You can actually just take two rows of a matrix and just flip-flop their locations. And so that's the way we show it is with the little double-headed arrows. We say, hey, everybody, I'm switching row 1 and row 2. You can't keep switching. Like you can't switch row 1 with row 2. Bottom line is, let me say this first of all, and I'm sure knowing how smart you are that you're saying something good. Just give me a second here. First and only thing I want is for that to go there. We clear? And then what else do you want to do?
You don't want to be at the third row, do you?
Oh, I see what you're saying. So you're jumping multiple things here. I don't completely disagree with what you're saying. So you're saying you want to switch. I think that you might be going too mega here, but I don't disagree. Like you're thinking way further ahead than I ever anticipated that you might. But for now, I'm just going to switch rows 1 and because a lot of times those things are going to work themselves out, Brycey. Like for us this early in the game, to worry about the lower right-hand corner is a bit premature because as we interact rows with each other, that 0 probably doesn't have a shot of staying there, quite frankly. So my primary objective is what I've drawn in yellow, and that is to get that 1 up there. Let's get that up there. So when we switch rows 1 and 2, and that's how you notate that again, we're just going to switch row 2 up to row 1 now, physically switching their locations. And then row 2, that's a little crooked. Let me try to draw that not like a 4-year-old that just smoked some crack. And then row 2 is going to come down here. And then row 3, I'm just going to leave alone. And I don't know if y'all picked up on what old Swaggy B was saying, but he's focusing on that 0 in the lower right-hand corner. And he's not wrong. But what I was saying is like, it probably doesn't have a shot. Like it's probably not going to survive all the stuff we're about to have to do. Right. So priority number 1, fill that upper left-hand corner. All right, from here, I'm going to give you guys a couple of minutes. You don't have a lot, but why don't you, I'll scroll across like this, and why don't you do a step, and then we'll compare. Peek up at mine. I won't talk a lot. Just peek up at mine once you're done with your first objective, and we'll see if we all agree. Okay. Assuming you've created a 0 in the lower left, you might want to peek up. Let's compare notes real quick. And then again, I'll go back to quiet mode, and now we'll move on to making new zeros. Okay. You all should have done, of course, row 1 plus row 3, right? To wipe that 0, to make a 0. Don't mean to interrupt, but your next step probably would have been to make that 0 in the top center spot. And to do that, you need 7 of the top rows added to just unmodified second rows. And you might think, well, gosh, I messed up my 1. Like I said earlier, I'm not worried about it being a 1. It's the zeros that we want to preserve, not the 1s. They'll take care of themselves later when we divide. Okay. Our next one is going to be a little bit harder. There's a little more meat on this bone because we have to do the double operators. So when you want to make a 0 down here where the 2 is, your next row operation should be double R2 plus 7 times R3. That's the best, most efficient way to make 7s and 2s collapse. Multiply 1 by 2 and 1 by 7. So again, feel free to, you don't have a ton of time, but pop your head up and take a peek. See if we agree. There's only one job left to do. Who's the number on our in our crosshair? No, I don't care about the negative one. There's two numbers, I guess. We have two jobs. Who are they? Yeah, we need these two guys to become zeros right here. So that's mission, like next in line is that. Yeah, so we're going to do -4 times the bottom added to row 2, and then we're going to do 3 times the bottom added to row 1, and then we're going to be home. Now, unfortunately, the clock, I mean, I work for the principal and I work for the school board and all that stuff, but at the end of the day, the clock is my boss. And the clock is telling me that I have about 1 minute before the bell rings. So we're going to pause right here. Obviously, no assignment on this. We'll wrap this up Monday, and we'll spend probably a couple days at least working on this. Where are we at? Kind of okay? Not bad? Operation making zeros, baby. All right.